So I'm Deepak Panickal, and this is my colleague Ewan Crawford. So here we are here to give you a talk on why should I use LLDB. So the idea is to present LLDB from a user point of view, to showcase features of LLDB, and just to help more people start using LLDB as their primary debugger. So I'll start off with a little bit of introduction. So we are debugger engineers at CodePlay. We have been working on LLDB for the past 3 years on customer projects. And in the past year, we've been adapting LLDB for Qualcomm's hexagon DSP, and we have been upstreaming patches to the community. So a little bit of information about CodePlay. So we are based out of Edinburgh, Scotland. It's a small company. We have around 35 engineers. So, and we work on both R&D and compiler debugger technologies. And that's Edinburgh Castle. So about the talk. So I'll start off with a little bit of motivation regarding why we are giving the talk, and talk about LLDB's command line interface and the MI interface, and move on to features regarding LLVM libraries, the C++ and Python API, and future developments in summary. So if you have any questions, please ask us at the end of the talk. Thank you. So LLDB, as you would know, it comes under the LLVM umbrella of projects. It has a very clean, maintainable plugin architecture. So, which makes it first it's very easy to develop stuff for it, and it's also very easy to add features. And almost all features in LLDB, say, if you consider debugger, adding a new architecture, supporting new object formats, new operating systems. These are all done through plugins, so it's very easy to add stuff and modify stuff. It works on all major platforms. It works on Mac OS X, FreeBSD, Linux. Windows support is coming up. It does run on Windows, but certain native debugging features are still not that up to speed. It has been the default debugger in Xcode for quite some time now. So yeah, what we want to do is invite more people to start using it as a primary debugger, and we aim to showcase a couple of LLDB's features from a user point of view. So I first want to talk about the command line interface. So I'm sure you guys have used a lot of debuggers. So LLDB's command line interface is very verbose. So you have, it's structured very well, and commands also have short forms for the power users. And there's tab completion of commands, which is not on Windows yet. And there's also a lot of settings using which you can configure the debugger to your own liking. And for people who have used GDB, it's a very easy jump from GDB to LLDB. A lot of commands are very similar, and if you want to look up more, as a reference, you can check out this link to see the actual mapping. So I will show a little bit of a few examples here. So as you can see here, these are the the GDB commands and how similar the LLDB commands are. So if you, for example, if you take this one, it's just to print out the values in that memory address, and in LLDB you have this long format, where things are very verbose and specified, but you can also use the same syntax, and it works just as well. So most of the commands are quite similar in GDB. So people who want to move out to LLDB they'll feel right at home. So I'll just now cover a few commands which would be quite useful to somebody who's planning to move over. First command would be the help command. It shows all the supported commands in LLDB, and you always get a very detailed help, and shows what you're supposed to do with it. And the commands are also classified. So there will be a command, there will be a subcommand under that. So here the example is for the breakpoint command. So if you just do help breakpoint, you can see all these subcommands underneath that, and this description of what it does. And for those commands, you can actually do help command and subcommand name. So here the example is help breakpoint set, and you can see the options that are available there. So you can, for example, you can do breakpoint set and give a file name to set a breakpoint in that file. And like I had mentioned before, you also have short forms. So if instead of typing in watch point set variable count, you can just do WSP count if you're quite familiar with the syntax. And regarding settings, there are many settings available. There's just two of those two examples. So here what we're trying to do is we are just saying that whenever there's a shared library event, such as loading a shared library, unloading a shared library, you just want the debugger to stop and give control to the user. And there's another setting where you can just redirect the output to a text file. It's just a few examples, and this is another command which is extremely useful. It's sort of like grepping through all the settings and all the commands. So if you want to just find out, okay, I want to check out what commands are available with this string. You just do the apropos command. You just type in that string, and you can see those are the available commands, and these are all the settings related to the system string. So it's very useful in finding out commands while using LLDB. Now this is, I'm just showing an example of how debugging looks like and how detailed and rich it is. So here I'm using the file command to load in an executable, and this is a verbose way of setting a breakpoint. So I'm just saying I want to set a breakpoint on the function main in the file example.c. Or I can use a shorthand way of doing it, similar to GDB, where I just say b factorial and it sets a breakpoint in the factorial function. And I just do run, and this is how LLDB shows the UI is. So it says, yeah, I've stopped at line 22, and it shows the source is actually shown in the command itself. And you don't have to keep typing in commands to see each state. You can actually see the thread ID, the program counter, where you're stopped, why you have stopped. So the stop reason could be anything. It could be like a shared library event. It could be a step in, step out, things like that. So it's always very easily, things are very easily visible to the user. So yeah, now I'll move on to talk a little bit about the MI interface. So the command interface is for the people who want to use the command line interface, and the MI interface is for using LLDB from an IDE. Now there are other ways of doing it, but the MI interface is quite closely related to GDB's MI interface, if you guys are familiar with it. So what is MI? MI is a protocol allowing a front end to communicate with the debugger in text form. It's just a way of it's a way for controlling the debugger. So there is a GDB-MI protocol which a lot of existing IDEs use. Those would be Eclipse, NetBeans, Emacs uses it, Qt Creator uses it. So you can control. So because LLDB-MI is exactly like GDB-MI, all of these IDEs would work right out of the box with LLDB. Now it's not completely supported yet. Eclipse works really well. I believe NetBeans also works, but support is being added every day. So if you can check out this link if you want to know more about the design of LLDB-MI. So I'm just showing just two screenshots from Eclipse, just to see how easy it is. And as a user, you don't really have to know that LLDB is actually running behind the scenes, because it just works for you. So here we are just showing a simple debugging example where you can see the variables here, you can see the register values here, and for example, there's the disassembly, and you can see the memory view here. So all of these features just work out with current tip. You can just build LLDB and use this on Mac OS 10, Windows, Eclipse, Windows, Linux. It works on all of these platforms. So yeah, now I'll move on to talking a little bit about one core feature of LLDB, which is it makes use of LLVM libraries. So what the benefit is that you get all of the following for free because it reuses LLVM libraries. So one thing would be up-to-date language support, because it uses the Clang compile infrastructure behind the scenes for expression evaluation. It can actually use the LLVM disassembler for disassembling instructions for many architectures. So the thing is that if you have already added a disassembler for your architecture, LLDB can just reuse that. And it has both IR interpreter and JIT-ting for complex multi-line expression evaluation. And JIT-ting is on supported architectures, and on other architectures you have the IR interpreter. And they both, leverage the power of Clang and LLVM. So it is pretty useful. I will explain more in the coming slides. So how do you use expression evaluation? It's just using the expression command. So it's just an example of, what if you type in help expression, you can see all these available options, and this is just an example of how you can run the expression evaluation. So yeah, this is what I mentioned about multi-line expression evaluation. So I can just type in the expression command and start writing in these commands, and it just works for you. As in, I can just print out and invoke a function in your program and just print out the values here, and you can actually do a lot of complex debugging scenarios with this. And you can also declare local variables. And yeah, this is another example. So here we are actually using C++ expressions in a C program. Now granted, this is not very useful, so it's just to show how easy it is. So here we are declaring a lambda and just printing out the value here. And this is another example where I'm just trying to print out members of a structure, and you can actually do proper type deduction, print out the values, and this all works really well in LLDB. Now this is an example of using the disassembler. So as you can see, the source is interspersed with the assembly. So here, if I do this -n, it actually is the function name, and by using the -m flag, I'm just saying I want to see the source along with the assembly, and it's very useful in complex debugging. So now I will hand over to Ewan to talk about the C++ API.
Cheers. Hi everybody. So Deepak's already talked about two of the ways you can use the LLDB interfaces, the command line interface and the MI interface. I'm going to talk about the third way you can use LLDB interfaces, and that's through the public API. So LLDB has a C++ interface. It's basically just a very lightweight wrapper around central objects in LLDB. And what that means is if you're a C++ developer and you want LLDB functionality in your code, you can integrate it. So this could be the complete debugging experience if, say, you're creating a GUI front end for the debugger, or it could just be individual pieces of functionality, like, say, disassembly or investigating object files. This is made available by just linking against the LLDB shared library or framework in OS 10. And it's also documented very well on the URL right here. So what I've got here is just an image kind of showing you some of the more important objects in the API, so you can get a better feel for it. So you basically have access to an instance of each kind of object from its parent. So although it looks a bit simplistic here, it's actually very efficient and very useful, and you'll see in a few slides' time it's still very powerful as well. But the kind of central object at the top, debugger, basically just represents LLDB, so that kind of owns everything else. And when you're using the C++ API, you have to initialize this before you can use any of the other API calls, just kind of set up your global variables, your global state, all that. And there's also a tear down call as well to kind of clean up everything else once you're finished. I hope you paid attention to this because I keep on referring back to it in all the examples, so you've had your chance. Right, so there's a C++ API, but there's also a Python API. And unlike the C++ API, which tended a bit more towards developers, the Python API has real end user benefits straight away right out of the box. So there's two ways you can use this Python API. The first way is as part of an LLDB Python module that you import into a Python script, the same way you import any other library into Python. That just means you can script LLDB debugging functionality. So that's really handy if, say, you've got a really complicated debugging situation where you have to continue past 10 breakpoints, then step up the stack for some, and then investigate some obscure variable. You just script it all here, and then it's all a lot nicer, a lot easier to repeat. It's just a nicer process. And then the other way you can use the API is part of an embedded Python interpreter inside LLDB. So I'll give you a few examples of how that's useful. And again, it's all documented on the LLDB website. So that API is exactly the same as the C++ API, it's all the same objects, all the same methods, but it's in Python. And the reason for this is because of a tool called Swig. And Swig stands for Simplified Wrapper and Interface Generator. What it does is you give it C or C++ code, and it creates a wrapper around that in a kind of target language. So here we've got our C++ API, and we want to create a Python wrapper for it. So that's very nice, and it means that this all works well. But what's especially good about it is its flexibility. So say you're a Java developer, and you really wanted LLDB functionality in your Java application, but it wasn't there. You can define things called interface files in Swig, and that tells you how you create the wrapper around the C++ code. So you can create your interface file for Java, and that'll basically give you your Java API, and you can just use that with LLDB use your LLDB Java API in your application. That's very nice. Finally get into some examples now, sticking with Python. This first one is pretty simple. What we do is we've got our LLDB Python module, and we're importing it into a Python script. All the script does, it's very simple. You give it a parameter that's a function name, you set a breakpoint on that function name, you just kind of start the process, break there, and then just print out all the variables. So we can't go through this just now. First thing we do, up there, import LLDB. Exactly the same way you'd import any other Python library. Exactly the same. Then initialize our debugger object. So if remember back from our image review hierarchy, that's at the top. So that owns everything else. You can construct basically everything else in LLDB from that. Very simple. And first thing we do construct is a target. So we kind of got a.out, just a generic executable we want to debug. Let's put that in here. Just using a nice API called create target with file. And once that's done, we actually want to create our breakpoint. We put our breakpoint in as a parameter here, insist.argv. Just be aware we've not done any error checking here whatsoever, so you might not even specify the parameter, let alone it be a valid function name. So let's assume here that it's all good. And there's a very easy way to use that, just breakpoint create by name. What could be simpler? Start up. Right. Got our target, create our process, launch simple, then just starts up the process you want to debug, and then we've checked we've hit a breakpoint. So stop there, we just keep on going down our hierarchy. It's really easy, really nice to use. Got process, just get the thread. We've got the thread, you just get the frame. Then once we've got our frame, just get all the variables. Easy peasy, get all variables. The API call just returns a Python list of all the variables in it, and you just iterate over them, print them out, which is really nice and simple in Python. You can see some kind of sample output there at the bottom. So this is quite a simple example, but I'm sure you can come up with your own kind of use cases where something really complicated you want to debug, and you wish you could kind of script it up so it's a lot nicer, and you wouldn't have to make mistakes and then start all over again at square one. So the other way you can use Python and LLDB is part of a Python interpreter. So this is exactly like any other Python interpreter you'd expect to use, just running from the command line, except it's inside the LLDB. So it's absolutely fully featured. So you can see here, we're importing external modules. Import math, use ceiling, just like that. And the way we get into this is by typing the script command. So script, I'll just drop you straight into the interpreter. Do all your code, do whatever you want, and then type quit to exit. Same as always, exactly what you want. If you just want to say put one statement, just do a script, then that command, I'll just run that command without dropping you all the way into the interpreter. Also, if you find you're typing out the same statements or same functions over and over again, it's just getting a bit repetitive, you can just define it in an external file, external Python file, whatever, then load it up with command script import, and just import it into LLDB as a module. You can also use the API inside the interpreter, so for things called convenience variables. So those are like instances of the LLDB API objects. So that's all your things kind of like debugger, frame, target, process, stuff like that. And what that means is you have access to the current LLDB state through these. So kind of got an example here with frame, and then you can kind of just use API calls on it, get stack pointer. It turns it in decimal, which isn't always the most useful format when you're debugging something. So you just use Python hex function, put into hex. This is really nice if you want to calculate some arithmetic stuff, and like say a stack pointer, you want to work out some offsets, you want to calculate some stuff really nicely, quickly. Inside LLDB, you don't want to have to start up another application, something like that. Just be aware though, these are called convenience variables for a reason. And that's because they don't have any real meaning outside of the interpreter. So say you modify something inside it, it won't actually update the state of the process. And likewise, if say you're in like a multi-threaded environment, if you're editing this in one thread and then another one change something, it wouldn't update, stuff like that. So they only have any real meaning inside the interpreter, these convenience variables. So just having an interpreter inside LLDB is nice, but it's not the whole benefit, it's not the full picture of having Python inside LLDB. There's also real benefits in terms of functionality that adds as well. One of these is the ability to define your own commands. So these are just like all the commands that come out the box of LLDB, except you define them yourself into a Python function. In order to do this, there's a specific definition you need to meet. And we've kind of got an example of it here, where we're trying to implement ls. I'm sure you're all very familiar with ls from Unix systems. You've got a directory, it prints out all the files. But this example specifically is taken from the LLDB website at the Python reference page. And if you're interested in reading a bit more about all this stuff, I'd really recommend checking that out, because it's packed with really useful stuff. But what we've done here is we have to, first off, give it a function a name, and that's just the name we want our command, so ls, simple. Then we have to give it these specific 3 parameters. Debugger, again, instance of our overarching debugger object from which we can get all of LLDB state, we can work out pretty much anything. End result is just the output we're printing back out. So we can implement this pretty easily in one line by using a third-party module called command, not to be confused with the parameter command. They're pretty similar. We just use that as a third-party library to call the ls binary, and just prints out the output. So hopefully this shows you that the ability to use third-party libraries really adds a ton of functionality to LLDB, because Python's got an absolute wealth of already implemented features just ready for you to use if you import the right stuff. And this could also be as complex as you want. Right here it's just one line, but you could have crazy complex commands that save you a lot of time if you put in the effort to write them up. So say you find this in a separate file, you want to load it into LLDB, you want to add it. You'll need to include also a wee function that I've missed out here that basically just registers it, so LLDB knows that you want to add it. But if you have that, then you just need to do command script import, so load up external files into LLDB. Then it'll see that you want to add this, and then away you go. You're sorted. Just put in your command and you can get your output. So although that's pretty cool, there's, in my opinion, an even better piece of functionality that Python provides, and this is the ability to run Python scripts when a breakpoint's hit. So, in kind of the same way, when the breakpoint gets hit, you have to define a function with a specific signature. Then the code inside it gets run. Right? So, this time the signature takes a frame variable and a breakpoint location. So a breakpoint location, basically every breakpoint can have several locations if its address is actually ambiguous. But by passing that in, that means you could say disable that breakpoint location after it gets hit once. So you could get a bit of a performance benefit, because it doesn't have to get hit tons and tons of times. Then you can just fill up with whatever you want to do in your breakpoint, and then optionally you can return false. Anything else, the breakpoint just does normally, returns control back to you, the process stops. If you return false specifically, then the process just gets automatically restarted after your code inside your functions run. This is really, really useful if you've got a breakpoint that's hit, say, like 100 times, and you're fed up of having to go continue every single time, because it's just tedious, boring, frustrating. Instead, you could just put, say, some logging functionality in your function for whatever you want to actually see. You just put it to a file, and then by returning false, it'll just automatically do that all for you in the background. And once you're finished, you can just read that. It's a lot nicer, a lot cleaner. And also it allows for some quite cool profiling ability by doing this, because you can maintain like a global state. So you can effectively almost script your own profiler rather than having to rely on, say, functionality of some additional tool you might have to use. So we've kind of got a final example now. It's a bit more complicated than the other ones, but it's a bit more interesting as well. What we've done is we've defined a Python function. What it does is every time a breakpoint's hit, it just walks up the call stack of the breakpoint, uses it, walks up the call stack. For every function name it sees, it takes that name and just adds it as a wee node in like a call graph. So we've got kind of a bit of sample of that here. So this is kind of taken from the popular like curl application. So you give it a URL and it just grabs all the data from it. So we've set this specifically on malloc, breakpoint on malloc, because that's, it's quite an important function call. Usually if you're looking for memory leaks or memory profiling, you want to know about it. But it's also a conditional breakpoint on 3 bytes. Why 3 bytes? Just because it keeps the graph small enough that we can fit it in a slide. Although we've still had to kind of miss out a couple functions here. But what's quite interesting about the graph is that malloc's getting called from a third-party library, a shared library that's getting linked in at runtime. So say you're hunting for your code, trying to find all your memory allocations, and you can couldn't work out where this was coming from, you couldn't work out where the memory leak was, you could do something like this and you could work out absolutely everything. You could set up conditional breakpoints, stuff like that, and then you can work it out. The graph itself is also getting printed out using PyDot module. So that's again, it's a third-party library you're porting into LLDB so you can print images using Python's multitude of additional packages. Just quickly kind of go over a bit of the code for this now. I missed out some bits of it again, so we've kind of fit it in. But first one we've got is kind of global variables at the top, just kind of representing our wee graph. Again, what having global variables means is that we can maintain a state between every time the breakpoints hit. So in theory, you could have breakpoints in different processes and even different threads and still try to maintain some kind of global state between them, doing something like this. But in our case, it's just in between individual hits the breakpoint, just maintains that. They've got our kind of matching function definition that you need to have in order for the script to be successfully, or function to be successfully run every time the breakpoint's hit, taking the frame and the breakpoint location. Then again, keep on working down a wee hierarchy of LLDB objects. You can get the thread from the frame, you can work out the number of frames from that, and just iterate over them as an index, and then using a really useful API called getFrameAtIndex to return the frame object at that index. Pretty simple, pretty clean. And then get function name. So again, another really handy function. What is this? If you've got a frame variable, it just returns a demangled function name if there's debug info available for it. There might not always be debug info available for it though. That's the problem. In which case, we've got kind of a wee if condition here where I've missed out what we actually do. But what we do is get the module name and an offset from it. If I jump back, that's what we've done with load crypto here. That we don't have any debug info for that, so we can't work out what module it's from, and then we offset for it. But we know that I compiled this myself, so we know the function names for that. Just keep on iterating over this. Keep on adding all the function names to our graph. Then once we're happy with that, we can return false because I don't want to do anything else as a user. The script's doing all my work for me. In this case, it's a conditional breakpoint that only gets hit once, so our graph's very linear. It only goes up and down. There's no multitude of calls. It only gets hit once, so it's quite simple. But once we're happy with that, we just use the script command. It's called jaw, and it uses the PyDot to print it out as an image. So that's it from me. I hope you've kind of enjoyed some of the examples and you're kind of keen to have your own go of Python and LLDB. I'll just hand it back to Deepak to wrap up the talk.
Thank you. So yeah, I'll talk a little bit about future developments in LLDB. So yeah, I had mentioned before about Windows support coming up. So we have some native debugging features in LLDB already, but it's being improved every day, and command line features in Windows is not up to par with as other OSs. And LLDB-MI support, we do support Eclipse and NetBeans now, but there's still considerable work to be done to make it perfect for other IDEs as well. So that's also something that's coming up. And LLDB already supports a lot of architectures. A few would be x86 ARM and 64-bit versions of those. But a lot more are being added, and it's quite easy to add an architecture if you have your own, even if it's an obscure architecture, it's quite easy to add it to LLDB. It's, because of the plugin model, it's quite easy to fit it in. And because it uses Swig to generate these API wrappers, it'll be quite easy to generate a C# API interface, and having a C# API interface would help for it to be used, from the Visual Studio APIs, and that's also something that would be very useful for the future. So when we started working on LLDB, which was say 3 years ago, there are not that much work being done on a daily basis, but nowadays it's getting very popular, and there are more than hundreds of commits happening every week in LLDB. So it is getting very mature very quickly. So Yeah, I'll move on to the summary and just summarize everything that we have talked about today. So why use LLDB? It uses, it reuses LLVM components. So it's ideal as part of an LLVM-based toolchain. So if you are planning to move to an LLVM-based toolchain, it does make sense to go with LLDB. You can easily, add features to it. It also comes under the same BSD style LLVM license, so it's very easy to modify it. Now, it's supported on all major platforms and supports many architectures, so it's quite likely that it will really run well on your platform. And the Python API stuff, which Ewan talked about, it has an embedded Python interpreter within LLDB, makes you write really cool scripts, really enhances the your debugging features. It also has a powerful multi-line expression evaluation within it. And for information on building LLDB, you just need to check out this link, and it shows you on how to build it for different platforms. So I guess that's it. If you need any information about anything, you can just contact us. And the Python examples that were shown in the talk is available at this link. And if you're an LLDB developer, that's the mailing list you need to contact to know any information about it. So thank you.
Thank you, Deepak and Ewan. And we have 6 minutes for questions. Who wants to start? Yeah.
I just want to encourage anybody here who wants to try it out on Linux, please use top of tree. Don't try the LLDB that comes from the distro. It's not going to give you a great experience.
Right. Okay, so now the question.
Deepak, thank you for the talk. Can I just play devil's advocate? You gave a wonderful talk that explained how LLDB could do everything that was in GDB.
Okay.
I sort of picked out just 2 things, I think, that make it different for the user. One is that you can actually use Python to invoke LLDB rather than just LLDB invoke Python, which is what GDB can do.
Yeah.
I can't remember what the second one was. If I've got an existing GDB, you haven't sold to me why I should switch to LLDB. And you've only partially sold to me if I've got a new architecture.
Yes.
Why should I implement LLDB rather than GDB? You have got a bit more on that, because if you've got LLVM, you've got some components there.
Yes.
So I'm just, if you could come to me, why should I switch?
Well, if you are already planning to move to an LLVM-based toolchain, say you're using Clang or any of the other LLVM libraries, it does fit in very well with those libraries. So that's one feature you have. The other one would be that it's very easy to add plugins. I don't think it's from what I've seen with GDB, I don't think it's that easy to modify GDB as compared to LLDB. So it's very easy to modify LLDB, and you can quickly add new features to LLDB.
Can I take a shot at this too? To me, the number one most compelling feature is that LLDB uses Clang for its expression evaluation, and GDB implements its own C++ expression evaluation, which is basically guaranteed to be out of date and kind of bad.
It's moved now though. GDB now calls into libgcc. They've got libgcc1.
As of when?
It was a last blue cauldron anyway, so it's been there for a year.
Yeah. For exactly the reason you just mentioned, which is that the support was getting out of date. So
Let's give a chance for this guys to answer questions.
Okay. How well supported are the x86 architectures? I know you said that they're there, but is the support tested? Is it run native?
I believe ARM is supported really well. So you can do iOS debugging from OS 10, and obviously that would work on ARM. So ARM is supported really well. And we have added support for Hexagon, so that also works really well. Now more architectures are being added. Now I don't know all of them, but yeah, there are some obscure other DSP architectures also being added. So yeah, it is quite easy to add new architectures. Yes. Yeah.
More questions?
Yeah, if you want to hear about Linux support, you can come to the second LLDB talk. It's about Linux support there.
What about multiple architecture support?
targeting multiple architectures at the same time.
So you can definitely support multiple architectures at the same time. So like if you want to debug two targets at the same time, there's no I don't think there is multiple debugging yet in LLDB. As in you can't for example switch from one architecture to another architecture in the same debugging session.
You don't need to rebuild the LLDB or.
Oh no. You can debug any architecture that's available. You don't need to rebuild LLDB. It's always available to you. So there's no LLDB 64 or LLDB ARM. There's nothing like that. There's just one LLDB executable, and you can debug everything that's already there with just that one executable. Yeah, I thought you were talking about debugging multiple architectures in the same process.
Well, that's the ideal. But
Yeah.
We have time left for one more question.
Yeah. For debugging, embedded systems, is there support for the GDB remote or the ability to use some sort of integrated emulator or simulator?
Yeah. So LLDB already supports. It has the GDB RP protocol support. So it has its own. So there are two remote clients already. There is one called Debugger, which works on iOS. That's not being further developed, but there's one being currently added called LLDB GDB server, which is a remote stub, and support is already also being added for the GNU GDB server. So that will also work quite well. So, it is being added now. So yes.
So thank you, Deepak and Ewan.